Hey scholars, so today we are going to be working on some new math concepts, and by new I mean we have actually talked about them once before in class, but for the most part this is not something that we've dealt with before. And what we are going to be working on today, oh, we're about to have a visitor. Hello Stokes, how are you? So what we are going to be working on is working to find, our objective is find the volume of a cubic shape. So, for those of you that remember this, the volume is the total amount that can fill a space. So, for example, in this coffee cup, the volume is the total amount that would fit inside this coffee cup. Hello again, little cat. If I have, thank you very much. If I have a book, right, the volume is the amount of stuff that fits inside this. So it's all of this, and all of this, right? It's how much fits inside. And so what we're going to be working on today is figuring out, well, how can I figure out what the volume of a cube is? And sometimes it's a little easier, sometimes it's a little harder. The first thing we need to remember, right, is that it's, again, and I'm going to say it one more time, volume is the amount of space that fills a shape. So right now we're working with cubes, and cubes are one of my favorite things to work with when it comes to volume because it can be relatively easy to figure out how much space it fills. And there's two ways to do this. And the first way that we're going to be working on today is by literally counting the cubes that fill the space. So for example here, if I look at these four, I'm going to take this one first. I'm going to call this A, and I'm going to say that first we're working with A, with cube A. So what I'm going to do is I'm going to count the total number of cubes, and I'm going to say, well, here's 1, 2, 3, and 4 cube units, right? Each one of these is 1 cube unit. It's this that goes down, up, and around. It's literally a cube, right? You could think about it if I drew a box and then I extended that box backwards, then, right, this would be a cube, and that's what this is. Since I have 4 of these, my volume, V for volume of A, that's the first one we're working with, is going to be 4, because each one of these takes up 1 space, 1 cubic amount. And so, therefore, since I have 4 of them, the amount that it fills is 4. Now let's look at B here. Right, B, it might be a little bit trickier, but I see 1, 2, 3, but if you'll notice, the third one is raised up. And because I understand the laws of physics, I know that this can't just be chilling on nothing. There must be another cube here. So again, I would say that that cube, even though I can't see it, I know it's there, is 4, right? And similar to this one, so I would again say the volume of B, just like A, is 4, because I have 1, 2, 3, and then 4 cubes that make up this shape. Therefore, it is also 4. Now let's do the last one together. Again, I see 1 cube, 2 cube, 3 cube, and similar to 4, there is another cube that's sort of holding up cube 3. This one's a little bit, you can see it a little bit better. So I'm going to say, all right, well, that is 4, right? So the volume of C is also 4. So what this shows you, and what I hope you've noticed, is that the volume of all of these is 4, but they all look different. The volume doesn't necessarily mean it's a certain shape. It means that there's a certain amount in a given space. Each one of these has a volume of 4 because there are 4 cubic units within the space, right? So let's do another few examples of this. So here, again, I'm going to say that I have the goal. I wish we had centimeter cubes to work with. We don't. But what we're going to do is we're going to look at each one of these and we are going to decide what is the volume of the shape, right? So here it's pretty easy. I have 1 cubic block. So the volume for figure A is 1. How do I know that it's 1? Well, I see that there is 1 cube that makes up the shape, right? Therefore, the volume is 1. Let's look at B. I see 1, 2, 3, 4, and 5. So the volume of B would be 5 because there are 5 cubic units in this shape. Or in other words, that shape can fit 5 of these, right? If you envision that the shape looks something like this. I know that's kind of messy, but if it looked like that, if I had a box that looked exactly like that, and the question was how many cubic units could I fit in, the answer is I could fit in exactly 5. Let's look at C here. So again, I want you to imagine that we have a box, right? Here's my box. It's a 3D box. 3D means that it's got up and down space, it's got sideways space, and it's got in and out space, right? So in this case, I should have done this a little differently, but we're going to work with it, right? I'm going to say, I'm going to just bring this over actually. I have a box that's this purple guy here, right? And the question is, how many blocks can I put in to fill exactly this much space? So let's count how many blocks we were able to fit in. We could fit in 1, 2, 3, 4. I always have trouble with the 4s. 4, 5, 6, 7, 8, and 9. So the volume for this one is 9 because I can fit in 9 blocks. Let's look at D now. So again, we can count our cubes. We could say, I can just count these ones really easily. I can say there are 4 here because I see all 4 of those. I can see 1, 2, 3, 4 on this side, so that's another 4. And then I have this one little guy that's just sort of hanging out. When I look behind it, I notice that there's an empty space. There's no block there. So that's not filled. So I only have 1 block here. So I have 4 blocks on this side, 4 blocks on this side, plus 1 block. D is also 9. So we just actually found 2 that look very different, but they can fill the same amount of space, right? Now let's look at E. Well, here I see that I've got 3 here. I have another 3 here. So this altogether, right, is 6. I already used this, remember, is part of these original 6. And I can actually see that on the other side, sort of behind the first 6, I have another 6. And I know that there's another 6 because these 2, even though I can't see what's below them, I know they're there because, again, according to physics, they can't just be floating in air. So I have 6 in sort of this first row, this blue row, let's call it, and then I've got another 6 blocks in this back row, the pink row. So 6 plus 6 is going to be 12. I have 12 blocks there, right? And you can even count. Again, I just sort of did a fast count, but you can count each one individually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I know there's 2 more below there because these 2 can't just float on their own. Last one. All right, I can say that I know that this, and I'm going to do different colors for this. I know that these 4 cubes, right? 1, 2, 3, 4. And if this one has 4, this bit here, then I can say with a good amount of confidence that this one, this set here is also 4 because I can see 3 of them, right? I can see this one up here is 1, 2, and 3, and again, I know that there has to be 1 below there, so this is also 4. And I can do that for each one of the following boxes. I can say I know that this one is 4 because I can see 3 of them, and I know that that third one can't be floating, so this is 4. And this one here also can't be floating. There are 3, and 1 has to be there. There's 4. And last but not least, this last one, also 4. So if I count these up, and I can't forget this one here, right? I wrote the 4 there, but let me write it sort of bigger here so you can see. 4, 8, 12, 16, 20. So the volume of this one is 20, right? And I sort of gave a verbal explanation for why I knew that. So this is the way that we can find volume, right? You can count each individual box, but the one thing you always need to keep in mind if you're doing that is there might sometimes be boxes that you can't immediately see, but you know are there, sort of like how you know that if I'm doing this, you might not have seen the coffee at any point, but you know it's in there because logically that is what makes sense. So here, because they can't just be floating, and here, because they can't just be floating, I know there needs to be something there, right? So that is how you find volume, and that should help you with the exit ticket that you have that is attached to tomorrow's problem set. All right, bye scholars, see you tomorrow.